EIP86 and EIP2938 are different Ethereum improvement proposals for account abstraction in the standard track 4 category, but unfortunately, none of them reached the final status. If you are wondering what the next proposal on account abstraction is, stay with us. Hello everyone, I'm Pooja Ranjan here with the 100th episode on PEEPanEIP. Today we will learn about EIP4337 account abstraction using Alt Mempool. EIP4337 is a standard track ERC proposal documented in September 2021, authored by multiple co-authors including Vitalik Buterin. This proposal initially proposed to bring account abstraction without making changes to the core protocol. As some of you may know, the earlier version of this ERC proposal offered account abstraction via entry point contract. However, after the merge, the working group behind EIP4337 updated the proposal. To provide an overview of the proposal with latest changes, we are joined by the author Yoav Weiss from Ethereum Foundation, along with other members supporting proposal 4337. Welcome to the show, Yoav.
Thank you. We're excited to be.
Thank you for having us.
Especially on the 100 episode. We are lucky.
Yeah, thank you all for joining us today. For people who aren't fully aware of the earlier proposal, you may follow episode 65 with Yoav and Krista. Yoav, it's been a while, so maybe we can start with a quick introduction of you and of rest of the team member working behind this proposal.
Yeah, so I'm Yoav Weiss. I'm a security researcher at the Ethereum Foundation, and I've been working on account abstraction for a couple of years now. I will let the other members introduce themselves in a moment, but I will briefly mention that this proposal, since we are not going to start from zero because we have many changes to discuss, I will just mention that this proposal, unlike previous account abstraction proposals, is in the ERC track, meaning that it does not require consensus changes. It's account abstraction by creating another layer on top of Ethereum to provide account abstraction through an alternative mempool. So, Dror, would you like to continue?
Yes, I'm Dror. I work on this proposal early on, just after Yoav started it with Vitalik about 20 years ago. Started created the initial version a year ago and spent the last year trying to find partners to work with it and, of course, solidify the protocol and improve it, as we will see later. Shahaf, you want to introduce yourself?
Yes, I'm Shahaf. I've been working with Yoav and Dror for several years now. We've been working together, and so naturally, I've been working on account abstraction as well with them. And here we are.
Right. Hi, everyone. My name is Tom. I recently joined the team and the foundation. And before that, I founded Portis, which was acquired by Shapeshift in 2020.
Awesome. Thank you so much for the introduction, everyone. And thank you so much for joining us on this special episode. Maybe we can just now kick off with the presentation.
Okay, yes. So what we've added since last time, okay, because we have been here a year ago, and we had a presentation where Yoav mostly did the presentation over there. But since then, we've added a few changes, or several changes to the core protocol in order to accommodate more useful use cases, both from accounts and other entities such as the PayMaster, that is the contract that pays for the gas and basically handles all the gas accounting logic on behalf of the account if it needs one. So what's new here? So the account changes we've added, which we'll discuss a little bit later, but briefly, we added the option. For example, we allowed the use case for adding session keys or changing the or aggregating signatures if we want to to make the transaction a little bit cheaper by batching it, and we basically allow that all in this version as opposed to the previous one. And we also, by having a little bit more relaxed storage rules access, basically a little less restrictive on the paymasters and on all entities, we also allowed other use cases that weren't previously allowed. So in the previous version of account abstraction on 4337, the paymaster itself couldn't even access its own storage or storage, for example, on another contract that is associated with the sender, with the account contract. And that, for example, blocked an implementation of a very common use case that is a token paymaster that basically pre-charges the user with tokens and refunds after the transaction finished. Now, in this version, we also allow that part, and that by allowing such storage access, we also had different security considerations that we needed to mitigate. And there comes the staking and reputations for all entities, which is a huge part of our effort in the past year. And the last part that we added is also basically pretty much finalized the Bundler's RPC API, both the production code for production and for debug, and added as basically a compatibility test suite for the bundlers, as well as a reference implementation and an SDK.
Just I would like to frame the changes before we start diving into individual changes. That in the previous version that we talked about a year ago, our focus was to get something out to start experimenting. So we focused on security, and we put many restrictions during validation in order to keep the system secure. And since then we collected a lot of feedback. We learned more about use cases. So the focus of most of the changes we're going to discuss today are usability improvement. We want to improve the usability of the protocol, by removing as many restrictions or relaxing as many restrictions as possible while remaining secure. So
right,
just to frame it at a high level.
Yeah, exactly. I mean, the last version was, while secured, was very restrictive in terms of what use cases were available back then. So allowing more use cases pretty much opened up new attack vectors that then we needed to mitigate and consider. And that was a huge part of our effort here, basically allowing more, but with the same security or as much as we can in order to make it usable and feasible.
Okay, thank you. Okay, before diving into the actual changes, let's look about the key challenges of account abstraction and why it is so complicated. Account abstraction comes to replace an EOA with a contract-based account. Now, EOA is secured by the protocol itself using signature, nonce, and gas fees. These are validated by the account and filled by the account and then validated by the node that takes this transaction into the mempool. Once you create a transaction, it is impossible for it to get invalidated. It is agreed to pay to the gas fees, and it is impossible for it to pay less. It can be replaced with something that pays more, but it can get any less. A user operation is a kind of transaction, but it uses EVM code for do the validation. And as an EVM code, it uses storage and it can be invalidated. So we lose that property that user operation is valid and cannot be invalidated. So our goal with the spec, most of the spec, is how to since we can't prevent this invalidation, how to make such invalidation expensive. So if you try to make a DOS attack on the mempool, you can, but it will cost a lot. If you want to block the system by bombarding it with transaction, you will have to pay for each transaction, and what we try to prevent is a snap, is a single small change that invalidates a large number of transactions. If you formally or mathematically way to put it is that putting any other transaction into the mempool should cost, or removing, sorry, any other transaction in the mempool will cost O of n, because they will have to pay for it. So it's not easy to invalidate them in a snap. Before we dive into the flows, this is a recap of what user operation is. It's a kind of transaction. In many aspects, it's similar to a normal transaction. You have the call data that you make a call, you have the gas limit, you specify the sender, the account that sent the transaction. We have a signature, but we no longer can assume that the signature returned the sender. We are not bound to ECDSA. We have the gas limit, and we have the gas priority and max fee per gas, like normal transactions. But we have some additions, since we have verification, and verification is a contract, so we also have verification gas limit. There are some things we can't do on-chain. It's not a fixed 21,000 that we can assume. So we have what we call a pre-verification gas, something you pay, but calculated off-chain. And we want to allow an external entity to pay for the transaction. So we added the PayMaster data into the structure. And lastly, because it's a contract and contract need to be deployed, and we don't know in advance how to deploy it, we have an init code. If you have an init code, it means it's a user operation that creates a new account on chain. So let's try to see how a user operation is created and sent. We have the user. The user is the normal user account. It creates a user operation and sign it, and use an RPC called send user operation to send it into the bundler. A bundler is usually a node. You can think of it as a node. It collects user operations, and then will later on, right? It collects user operation, put them into the mempool, and later on put them into a transaction. So we use the term bundler because not all nodes will create bundles, but it is very tight to what a bundler is. And the contract entry point. The entry point contract, this is the main contract we created. It makes the protocol tick. So an account, and this is the account, the contract account that will eventually make the call. But we are now just putting a transaction into the mempool, so we're only validating the transaction. The way the bundler does it, it make a simulate validation view call. It is a trace call. We'll see it in a moment. It make a simulate validation to execute this validation function. This validation validate the signature, validate the nonce, increment the nonce, and pay fees for paying for this transaction. After this validation, the bundler performs some checks on this just executed transaction to make sure that the code that it executed is good. For example, that it doesn't use opcodes that we know can be used by malicious actors. We will go into that later. And then it adds this user operation into the mempool. This is a simple transaction that of an already existing contract, but if the account contract is not yet existed on chain, then the first user operation will include init code. And by including init code, we means it contains the address of a factory contract. This factory contract will create this account, everything within this view call, and then we will be able to call the validate on this newly created account. We cannot validate an account before it is created, so we create it just for the simulation and then validate it. And as we said, if we want to use a flow that use a different contract to pay for the call, then we have a PayMaster contract. So again, this user operation specify within the user operation the address of the PayMaster and maybe some extra data that it uses. And after validating the user operation that validates signature and nonce, as we said, we also contact the PayMaster contract to make sure that it agrees to pay for this specific transaction. And if you notice, the account doesn't pay. In this case, the entry point doesn't ask the user to pay anything for this transaction because it will be the PayMaster that will pay, and the entry point contract manages the balance. In this case, the PayMaster pays through its previously deposited balance within the entry point. Again, the validation rules applies for the PayMaster and the account because we as the system, as the entry point, cannot trust, and bundlers, we cannot trust any external contract. We don't trust accounts, we don't trust paymasters. We validate, they don't try to perform malicious operation on the network. So, okay, the user operations are in the mempool. We have multiple user operations in the mempool. Just before that, this flow just shows that a single user operation can include initialization and validation by a paymaster, and of course the mandatory validate user op. In the slides, all the rest of the slides, I will not show all these entities. I will just specify the validate user op because this is the main one, but any operation can contain a factory if needed and a paymaster. So in the next slide, we see the flow that a bundler does in order to create a bundle. A normal node collects a transaction from the mempool, and since it validates when they were entered to the mempool, they are still valid. The only small check it has to do is to make sure that the transaction was not already replaced by checking the nonce. In our case, it cannot do any short circuit. It has to do a full simulation. This is second validation. We call it the second validation. The first validation was when this user operation entered the mempool, and now we are doing the second validation just before putting it into a bundle. It scans the mempool, whatever order it likes, probably takes the highest paying user operation first. Call the validation function, and add them, again, including the storage validation, everything, and add them to the bundle. Once it collected enough user operations, it creates a transaction, a single transaction called the HandleOps, and send it to the entry point contract. This transaction performs all the validations on-chain, and after all validations of this bundle succeed, it performs the execution. It calls the call data of all these user operations in order to execute them on-chain. Again, the validations are known to succeed because we tried them all off-chain. And the execution, just like normal transaction, they may or may revert or not, but at this point we know that they are all paid for either by the account itself or by the PayMaster. After the execution, there is of course a loop of refunding the excess fund, just like a normal transaction, and paying the collected fees from all the bundle to the.
Just to interject here, as you can see here, this slide is, I believe, is very important because it pretty much shows the security considerations and the roadblockers that we had during the development of the CAP. In that, we have several invariants that we have to keep. Okay, in contrast to a normal Ethereum transaction, as Dror said before, that is the validation between simulation and execution on chain, okay, between the first simulation and when it first enters the mempool, and the second simulation right before it is included in a bundle. We both have to keep that the validation stays the same, and the validation is exactly the same once it runs inside a bundle on chain. Okay, when the bundle calls HandleOps. So there is the first simulation when it is included in the mempool, then when it is included in a bundle, that is the second simulation, and finally on execution when it runs on the actual blockchain. Now, the second invariant that needs to be said here is for the security of the account of the wallet is there is a coupling between the validation and execution, because the entry point is a trusted contract. the validation and the execution must be coupled in such a way that only one execution, and exactly one execution is called right after a validation and cannot be called otherwise. Okay, so Dror, you can continue, please.
Okay, thank you. Okay, let's dive into the actual APIs and the modification. This is the API of an account. It's an interface called iAccount, and it provides a single function called a validate UserOp. Validate UserOp has one significant change from the previous release, is it returns validation data. It receives the user operation itself. It receives the hash of this user operation, and it receives the missing funds. What is needed to be paid to cover this the max possible gap, the max possible cost of this user operation. Validate UserOp is expected to return if it succeeds, and it reverts on any failure, like nonce on other things, it should simply revert. There is two major cases in which it should not revert, but should instead return a value. The validation data contains a time range, which is a way for the UserOp to signify that it is valid only in a specific time, until a specific time, or starting from a specific time. As we said earlier, validation can't use a timestamp or block opcodes, because this will allow them to enter the mempool and get invalidated later in mass. So we don't allow them to use directly these opcodes. What we do is allow them to return a range, and then it is the entry point that will prevent this user operation to be included on chain if it is outside of the range. And of course, the bundler will not attempt to put it on chain if it's outside of the range or very close to that. The other return value we add, return value, is a signature check. In the first release, we reverted on signature check, which is obvious. This is the major thing you want to do in validation. But when discussing with wallet developers, we understood that it prevents a major use case for wallets, and that is estimate a transaction. You can't estimate a transaction if it reverts. So instead, the validation returns a marker whether the signature is succeed. It returns zero address, meaning yes, I validate the signature, everything is okay, or one saying I checked the signature, it's wrong signature. During estimation, the wallet will put some bogus signature that will pass all the size checks and everything, but yes, it will fail signature check, but it is okay, it is estimation. All the estimation will continue. It will work only during estimation, because HandleOps, the actual transaction that will put a bundle on chain, will of course revert unless it returns a zero. There is another special case, and that is using a signature aggregator. If my wallet is using a signature aggregator, it means there is another contract it trusts to do the actual signature check, so it returns this as an address. Instead of saying zero, everything is okay, it says, ask this one, ask the signature aggregator whether it's correct, and it signifies to the entry point to contact this external contract to do the valid signature check. We do provide in our repo some helper classes, like a base account to do the basic logic of a generic code that every wallet does. And we have also a simple account, which is an EOA-like minimal proxy contract. But I wanted to put the basic, very minimal validate UserOp. It is based on our simple account, but packed only into a single method, so it will fit a single screen. So we see the validate UserOp. It validates first that it is called from the entry point. Then it calculates a hash and recover to check whether it is the owner. The owner is supposed to be a member. If it fails, it sets the validation data into zero. This is the simplest way to do a validation if you don't care about a range. We have a helper function if you do support ranges to pack them into the validation data. It checks the nonce, that is, it makes sure that the nonce is valid for the current transaction and increment it for the next ones, and pay in case it needed. PayMaster, again, the same change happened for PayMaster in that it returned validation data. It can return validation data just like an account, like if you have a PayMaster that agrees to pay for a coupon for a specific time range or something like that. Another use case is that another use case for a PayMaster is what we call a verifying PayMaster that uses an external check. So again, it needs to skip if it has a signature check. And as we will see later, a PayMaster used to be in the previous EAP whitelisted. Now we support PayMaster that don't have to be whitelisted. In most cases, they will have a stake, and simple PayMaster like verifying PayMaster can go without using stake. Another change we have with the factory. In the previous EAP, we required an entire create to init code to be included in the user operation. We understood this is both limiting and excessive gas-wise. So instead, we provide the address. The init code is the address.
The address of the factory plus the call data that is being this address will be called with, right, to create the account. Okay, that way we also support other existing solutions like the Gnosis proxy factory that is mentioned here.
It also allows very easy way if you have a factory that is valid on different networks, then also the created contracts will be the same on different networks. Okay, I'll say that this is a sample minimal factory. Again, I repeat here before we go into the changes to the protection rules we have, our key challenges, and yes, what we had tried to do is prevent denial of service on our network, on the network of bundlers, because our validation is more complex, so we have to protect them.
Yes, so that is a reminder. Yes, as Yoav said initially, that in the previous version we pretty much focused on security, and now we wanted to lift some of the restrictions on the usability part, but also keeping the security in mind. So that comes here comes the protection rules that we see here, and why we were able to relax some of them and to still keep the security intact.
Okay, yes. So the protection rules, sandboxing is validation should run the same on chain. This is requiring that the code will not be able to detect that it is running in validation mode. Isolation is user operation should not share state. Each user operation should be on the access itself. We were able to extend this in this version. And staking is a mechanism for us to apply reputation mechanism to paymasters, and not only to paymasters, so that they will be able to use their state and support multiple user operation.
By staking, we allow an even more relaxed storage access and even more use cases.
Yes,
with the trade-off of having to stake. Now, it's worth mentioning that the stake is never slashed on chain, because the damage that can be done is also not monetary, at least not directly, not by causing reverse on chain, but computational, like the CPU time off chain for the bundler. So staking is basically a mechanism to mitigate the CPU abuse that any malicious entity here can cause the bundler.
If you look at the code validation rules, these were extended a little bit from the previous version, but again, we block any user operation that allows to understand you are running in a sandbox. So We block multiple opcodes. We check the code that you access. We try to block anything that can cause a difference between the validation and execution. Like you are not allowed to access an EOA. There is no reason for you to make a call into an EOA, even though it doesn't revert, because if someone deploys something there, it will get reverted later. This is part of the thing that we block. This is one thing that we added in this version, but again, it's more blocking malicious attempts that we're trying to keep. What is more interesting is the storage rules. An account is allowed to access its own storage. And also we extended that also entities like a PayMaster, a factory can also access the storage of an account. It can be directly by the account itself or most likely by a accessor method of the account itself to access a storage in the account. What we do allow in this version is we also allow reference storage. A storage that is its address is not directly, but it is based on a hash of the account itself. So you are allowed, like if I'm a PayMaster, I am allowed, or the account itself, I am allowed to access a token balance of my account because a balance of is basically a mapping hashed by my account address. So if my validation rule allows me, or through a PayMaster, if I only own a specific NFT or token balance, you are allowed to access this storage. Staked entities, and by entities, we extend it to all entities in the contract, not only PayMasters, but also the factory and the in accounts and aggregators. They are allowed to access their own storage. They're still not allowed to access arbitrary storage, but they are allowed to access their own, and again, reference storage slash like the account storage. So a token PayMaster, for example, it can access its own storage and access the account storage, which means it can transfer value from one to the other. So this rule allows having a token PayMaster without being whitelisted. Anyone can create such a contract. Yes, it has to be staked, but again, it's not something that we ever slash. It only validates that the logic runs, it doesn't attempt to attack the system. A set of RPC APIs, send user operation was there from the beginning because this is the way to send a user operation. We also added equivalent user operation to the normal transaction. Like you can estimate user operation gas, which run your transaction and perform an estimation for all the gas parameters you need. You can receive it from the network, the user operation itself and its receipt, and supported entry points is needed to understand whether you can work with this bundler. One of the features we added to this version is support for aggregation. Aggregation means there is an entity that holds a single signature for the entire bundle. The flow become a bit different, that immediately after validating a single user operation, we validate the signature of that user operation. But just after collecting all the user operation, we aggregate them using the aggregator and collect all the user operations, all the signatures into one signature. And on-chain, just before running this bundle, we call this signature aggregator to validate all these signatures. This mode will be useful on L2s, where the CPU cost is far, far cheaper than a cold data cost. So saving the size of a signature for each user operation will add greatly to the transaction. Lastly, something we worked is that not only we created the reference bundler, we also created spec tests. It's a set of Python tests that test a bundler to validate that it runs all these rules and that is compatible with each other. This is still a work in progress. We are currently, I believe, 7 bundler implementations, all trying to make sure that they won't run in production and be able to pass all these tests. This is still work in progress. We're still adding rules with these with the community to make all these bundlers live. So hopefully soon we'll be able to release them on the mainnet. Final words, Yoav?
Yeah, so regarding the Bundler-Spec test, the reason it's important is that there is now a work group. I mean, when the EAP aims to have a mempool, and we did everything in order to make this future mempool secure against DOS attacks. But currently the peer-to-peer protocol is not ready yet, and there is now a work group of bundlers working on this protocol. But if they would be incompatible, if they apply the rules a bit differently, it would cause fragmentation, because then these bundles would not be able to talk to each other in the mempool, because they would not agree on the validity conditions of user operations. So the purpose of these tests is to enable having a unified mempool, and then all the bundlers that pass the test know that they can be a part of this mempool. So I think we covered all the changes we made, or at least all the major changes. And I think if we have enough time, we can go through some questions.
Great presentation, nice talk. It is interesting to learn about the changes since we last talked. Addition of PayMaster, and also the proposal provides security from DOS attacks, and attacks by malicious parties are good to have a unified mempool. Glad to know the proposal is at a better position to be moved forward. I think we do have some questions for you. Maybe William, if you would like to start with the question you have.
Yeah, sure, that'd be great. So I wanted to ask a couple of questions specifically around simulation. It could be that this is stuff that was covered previously, not here, since it seems like the focus here was more on changes to 4337. But in general, when looking at like general on-chain transactions, oftentimes one of the things that happens with simulation is that conditions change in between the time that the transaction is simulated and where it's executed. Sometimes even in the same block, you know, I simulate hitting a view function and then I throw in a transaction, but earlier in the block, something that changes the conditions happens. So what have been your findings as to when simulation is useful and how useful it is? And also, I guess I should put on a little bit more to that, because it sounds like in 4337, there's a lot of effort being put in to make sure that the transactions that are getting executed are ones that have the exact same conditions that they were originally simulated under, which also affects UX, though. There are a lot of things that'll be very hard to put through 4337 then. What's your approach to when simulation is useful and how it's useful, and what kind of a simulation is useful?
Yes. First of all, when we talk about simulation, we talk about simulation of the validation. We are not simulating the entire transaction because we don't care. And the validation covers just the account validation to accept this transaction into the mempool. So it checks against replay. It checks that the signer of the transaction is allowed to perform the operation, and it checks and it pays for the gas. So if there are some execution-specific limitations, they don't have to fit into what we simulate validation. That said, so it doesn't really limit. It limits the validation to use storage specific to the account. Yes, the owner, the signature, the nonce, all are things related to the account. So yes, there is a limitation. I agree. Not everything you will think of as a validation can fit into validate a user op, but everything that does relate to the acceptance of the owner or the rightful executor from this account is there.
Mm-hmm. So just to make it concrete. To make it concrete, since when we say simulation, we talk about validation simulation, it means that, let's say you have a transaction you're using an operation to perform a trade on a DEX, and maybe the trade will fail because the price has changed. That's fine. That's fine. We don't care about it. We don't care if this state has changed. The only state we care about is the state of the account, meaning the nonce, the keys. So unless somehow the keys of your account have changed or the nonce has changed, then the rest of the state doesn't matter. It doesn't matter for simulation.
Okay, so just to clarify, an account can invalidate its own user operation by sending a transaction, even without the entry point, just directly to the account. It can invalidate its own user op. Okay, but what we wanted to keep is that in order to invalidate this the user op, which can happen again, and it will only cost gas for the bundler. It will only cause the CPU usage once trying to include in a block, okay, in a bundle. And what we wanted to keep is that one change or one transaction with can only cause one store basically can only cause invalidation of a constant amount of user operation. It cannot invalidate an arbitrary n number of user operations. Now, it is possible still to, as you said, if a transaction right inside the block, before the bundle is executed, it can still invalidate it on chain. But that's why our bundlers basically need to work closely to a block builder, or basically, for example, a service like Flashbots, or any kind of block builder that basically can guarantee that the transaction will not, the validity will not change between the simulation and the execution.
Got it. Got it. One more question for me, maybe before I hand it back to Pucha. 4337, in addition to the actual EIP, the actual smart contract implementations, there's probably more that we need to see before we can actually, I would say, as looking from a user's perspective, until a user is interacting with 4337. In addition to figuring out, the P2P protocol, the contracts, what additional tooling do you think that 4337 needs to actually be delivered as something that's impacting dApps that people are interacting with, whether they know they're interacting with it or not? And how far out do you think we are from tooling like that?
Tooling for whom? Many wallets are trying to implement and support account abstraction, either solely with account abstraction or in addition to supporting UA accounts, like adding an SNU type. And in most cases, application will work just the same with the account abstracted accounts as they work with any other account. That said, there are applications that don't work well with accounts. If you have an application that you fail to run easily with GnosiSafe, it will probably be hard to use with a wallet that based on account abstraction. So there are the first thing that need to be done is to have to have wallet applications, so either browser extensions or mobile applications that will work with account abstraction. And the next thing, once there are such wallets, is educating applications to understand how to fix these issues, these incompatibility issues, because again, applications usually will not have to support account abstraction. They will have to support contract accounts, and there are several others in the ecosystem, and account abstraction goes into this category, and hopefully there will be many of them. So it will help to make them make the required adoption to support such accounts. That said, after there are enough applications out there, there are some features of account abstraction, of course, that application will be able to support. So once there is adoption, we want to see a tooling that will be defined somehow in communication with the wallet accounts, like an application that want to use a specific PayMaster. Like you have an application that wants to provide its own payment for these users, so it provides a PayMaster. This requires an API between the application front end to the wallet extension to provide a PayMaster to put into this request. So these are some things that need to be added later. And to define standard for them, between a standard API for them.
If I might not be understanding you right, so I'd like to just maybe try and work with an example then. So, I mean, the first thing that you mentioned is wallet tooling, that wallets will know how to enable users to have contract accounts, kind of unlock the potential of those accounts. So that would either be kind of like the current wallets in the ecosystem or even completely new applications springing up based on 4337 styled accounts. When you're talking about the way applications kind of interface with 4337, I wasn't sure what you meant though. Do you mean like, let's say we take something like Ethers, which is a very commonly used library in JavaScript for interacting with the blockchain. So a lot of times when there's a front end, a lot of times it's using either Ethers.js or Web3.js to make calls to the chain to get the wallet to pop up for a transaction, querying data, whatever the case is. Are you expecting like, you know, as a developer trying to develop a front end for a dApp, I wasn't sure if you meant that you're expecting the same kind of functionality that's used right now to get overloaded to also include 4337 accounts, so that as, say, a JavaScript developer using Ethers, maybe the Ethers implementer or implementers need to work, like, you know, behind the scenes to kind of overload functions to also include 4337? Or are you expecting kind of new dev tooling to spring up to kind of, like, and how thoughtful do you expect a dev at the other end of this to have to be about it? I guess, is that clear? I'm not sure I'm asking that clearly.
Yeah, I think it is. What I'm saying is that a wallet, I expect wallet to provide an API, to provide a standard API, and so that application will be able to continue and work just as they are and support account abstraction. So some applications will be able to use it. Some application requires new API like permit. Permit is something that you cannot do with a contract account. You need something else. So if you want to swap tokens, you need some way to provide the approval. The nice thing about contract account is that in a single transaction, you can do both approve and transfer, but you need a new API for that. So yes, for that, you will need tools like Ethers, Web3, or external tool to be able to support account abstraction. For the basic functionality, applications can work just with the account and continue to work. So yes, there is a need for tooling to support, in order to support some interesting scenarios, like, and we'll be able to have specific support for account abstraction for 4337.
So I would just add that regarding the adding support for 4337 for some development tools, we are working on adding this support, but it's a community effort. So so we expect that other projects will also help, and we also and the Ethereum Foundation will also consider grants for projects that add such support to existing tools or developing new tools for this. So feel free to reach out to us, and we'd love to support any such project.
Thank you, William. Talking about grants, I would just like to share this information that Ethereum Foundation is currently considering grants. They have over $1 million for education and tooling support. They have a wish list. So if anyone interested, they can probably make their application before 27th of February. I have a few more questions here for the guests today. In brief, if you have to say that, what would be the main reason for motivation to change the approach of account abstraction? It seems like it is an extension to the earlier version, but what would you consider the main reason for the change?
Then the primary reason is that we wanted to keep improving usability in the first version, we wanted to get something out since it was already taking a long time. So we decided to put all the restrictions in place in order to keep it secure initially, because relaxing security requirements is easier than adding them later for compatibility reasons. If someone develops a wallet that relies on a feature and later we have to take the feature away because we discover a protocol vulnerability that cannot allow it, that's a problem. So we started with a more restrictive version. And then the focus in this version was to find ways to stay secure while removing some of these restrictions. So that's the part. And beside that, we worked a lot on adding some new features, such as the signature aggregation, which initially we didn't consider, but it turns out to be important on rollups, in order to reduce the L1 call data cost, that is the primary cost for rollups. So we needed to add some of this, and in general, we needed to make it's going through a maturity process. So I think the EAP and the code is much more mature today than it was a year ago.
That sounds interesting. Is there a possibility of seeing some more specs changes to the current proposal, maybe to add the signature aggregation?
So signature aggregation has already been added, and we also have a sample aggregator for BLS signature. So this doesn't require additional changes, but it's still possible that in the future we'll add more capabilities. Whether it would be through the same ERC if it is a core part, or more likely through a future ERCs on top of it. So so we're going to keep working on it. This is not the last release, but we are going to release it and make it possible for project to start using it and experimenting.
That's right. From a proposal point of view, like from an EIP/ERC point of view, it's a general recommendation that the smaller the proposal is, the greater chances it has to be coming up as a final, like as a standard for community to maybe able to use. However, we can always keep proposing new changes, which could be the extension of the present EIP. So if we do not see anything like right now to be immediately getting in, probably we can move this proposal from draft status to review status, and other statuses followed by review.
Yes, so I think you are right. We shouldn't add any more functionality to this ERC. And there are several functionalities we're already considering, but will be added as separate ones. However, before trying to finalize ERC, I think we would still want to collect some feedback and to keep testing for security vulnerabilities, so that when we decide to set it as final, we know that the protocol is really secure. And since we are also not in a rush to get there, because since it doesn't require consensus change, there is no hard fork. Nothing stops the community from using it right now. So I think it's okay to take a little bit more to make sure that it's really secure before finalizing.
Absolutely. That's a very good idea, to have the assurance of sending out a proposal to the community when we are confident that it is safe to be used when it comes to wallet-specific use cases. However, the present status of this proposal is draft. So draft is something like when proposal is in very early stages and it's not ready for even getting implementation, it's not ready for project. So recently what we have done is we have started sharing warning messages along with the proposal, depending upon the status as it is. So for a proposal in draft, it is in very early stages, even not ready for review, but it seems like this is already ready for review. A lot of things going on in the background. A lot of implementers are there. So I probably think that it would be good to have it in review so we get more eyes to it. Even EIP editors will pay extra attention. And when we move from review to the last call is a duration where it stays for 14 days. And there we get the final feedback. So obviously we can move to the review, I think, and we'll keep it there for some more time till authors get confidence and then move it to the last call.
Right, thank you. Yes, so we should consider that. That makes sense.
That would be great. So we generally try to push proposal to move to the final status, obviously when authors are comfortable. So we can start promoting that EIP to the community to be implementing in their projects. Before it reaches to the final status, there is always a message that it is not fully ready to be implemented in the project. And because I'm aware that many wallets have started implementing this, so yeah, I think it's a good idea to keep it moving.
Yes, I agree.
All right, talking about the security and the confidence that we would need. I have heard about an audit, an external audit for this particular proposal. If you would like to take a few minutes and talk about what were the important features for consideration and were there any significant recommendation from the audit team?
Yes, the latest version is going through an audit. It's actually finishing the audit now, and there are no critical findings. We did make some changes to accommodate things that came up during the audit, but nothing critical. And the focus has been on both the contract security to make sure that that wallets that use it are safe, and also on the mempool security, on preventing DOS attacks. So the auditor spent a lot of time thinking about such attack vectors, ways to cause mass invalidations. So I think that's pretty much it. Dror, Shahaf, was there any other focus that you think we should mention?
No, I think you covered it pretty much. What we obviously put emphasis the most was the core contracts, and there were no critical or high severity even issues on in there, and only some issues on our samples that we already addressed. And yeah, so that's it. We are currently finishing our security audit.
That is good to know. Like when anything related to wallet and any proposal that may include funds comes up with an audit, it always gives more comfort to implementer as well as to the end user. So all the best. I hope that it goes with like a good result and no more further changes needed for the original specs.
But I would add regarding the audit, despite having the protocol, the contracts audited, I think that any wallet developer that relies on it should also be audited and should take our contracts into account, because the more eyes on the code, the better. So I would urge anyone who develops something on top of our contracts to also audit.
Yeah, that would be even better. Any project, like any DeFi project, if that is audited by a third party to ensure that it is properly done on contract level, that is additional layer of security that we are providing to users. Yeah. I have two more questions. One is related to the backward compatibility and changes with future Ethereum proposals. So the EIP suggests that the proposal does not have any issues of backward compatibility for Ethereum as a whole, because it is not changing anything at the core level. But unfortunately, it is not easily compatible with pre-4337 accounts. Is there a workaround for projects to resolve this issue of incompatibility?
In what sense is it not compatible with existing accounts, like with EOAs?
No. The only thing it isn't compatible with the EOAs is that EOAs can't easily become account abstracted because they are not contracts. That's true. EOAs currently are bound to be an EOA. Yes, we are thinking, and we have in the pipeline some work to try to enshrine it 4337 into the protocol and eventually add a way to convert existing EOAs into account abstracted. This is a very early work, and there are many issues regarding it, regarding cross chains and other aspects. We don't have any conclusion about that. I cannot say that it will happen anytime soon, or if at all. We do want it to be able to be heavy, though. Yes.
All right, not a problem. I'm sure that there is another similar proposal, like not exactly the account abstraction, but the EIP 3074 auth and auth codes is another popular proposal for like wallet, and part of it is also helpful for account abstraction. Do you see the wallet supporting 4337 will be compatible with EIP 3074 if that is approved on core protocol level in future?
No, first of all, they are not contradictory. Second of all, they are not account abstraction. The main feature of account abstraction, they don't do. They aim at gas abstraction, and they have some cool feature for that. But and actually, if and when 3074 get accepted, it will allow making slightly cheaper 4337 accounts. They can work together, but it is not required because you have a lot of reservation about it. And
I think, I mean, my reservations about it were security related. They were not related to account abstraction. But actually, having said that, if a chain has EIP 3074, then it actually becomes easier to implement ERC-4337 accounts, because it would become easier for an existing EOA to refer to this code. So I don't think we'll have the time to dive into the pros and cons of this approach right now, but it could actually be used. So there would be some interesting use cases on a chain that supports this EIP. So if it is merged, we would love to explore this the synergy between the two.
That is good to know. I mean, like if a proposal which is proposed in future may be becoming a part of Ethereum mainnet is going to help the existing proposal, that is at an added advantage for implementers of the proposal 4337. One final question related to the future compatibility is about the deactivation of self-destruct. Like, it is a proposal for future consideration of blockchain. Do you think it will make any effect to projects who have already implemented 4337?
Yes, it will make our life easier. We don't like this opcode. I think few people do. So self-destruct. Many of the attack vectors we had to mitigate are due to self-destruct, whether it happens during validation, which of course we banned. So we had to ban the opcode. So in that sense, there is no compatibility. There can't be a compatibility issue around it, because the EIP already bans the use of self-destruct during validation. But we had to take into account attacks where the code of an account changes between the first and the second simulation, for example, or some library gets self-destructed. So a lot of mitigations were put into place, and the bundler has to implement them in order to protect itself against self-destruct attacks. So once it's removed, the bundlers can become simpler. We can just remove some security checks.
So we are already getting more support to the deactivation of self-destruct proposal.
Oh yeah.
Good to know. All right, it's time to wrap up. Is there anything that you would like to add or share with the EIP implementers or the Ethereum community in general?
No, I don't think so.
Very well. I think the presentation and the question and answer session has already covered most of the important aspects related to this proposal, and we hope to see the audit result and the testing, the Builder-Spec testing that is currently in progress to get it completed, and we'll be happy to move this proposal to the next status. EIP 4337 defines the RPC and protocol used by users and nodes to communicate and make sure user operations are decentralized as normal Ethereum transaction. It is a useful feature for decentralized projects to provide flexibility to wallet devs and end users. With many advantages being brought to wallet developers related audit done, I see this proposal to be in a place to be moved towards final. Yoav, Dror, Tom, Shahaf, thanks for joining us today to talk about account abstraction, EIP 4337 and its future plan. I suppose that's helpful for many hackathon participants and projects considering implementation of this proposal. And on this note, thanks to everyone watching or listening to this episode. Should you have any question, let us know in the form available in description or leave a comment or reach us at eCathoder's Discord. Check out description for link to useful resources and guest Twitter to follow. We'll be back with another interesting Ethereum topic, so stay tuned and keep sharing your love with Ethereum cat herders. Cheers.